Question 2.2.3 says show that the pattern is increasing for all values of n. So in this case, we want to prove that the smallest value in our pattern is positive. Now we know for a quadratic graph, the smallest value is the turning point. This trope is similar with the quadratic pattern as well. The smallest value will be at the turning point, the minimum point. So since we can express our pattern as in this quadratic format 6n squared minus 9n plus 6, we can find the smallest value in this case. Therefore, if we say n is equals to minus b over 2a, which is synonymous to the function x is equals to minus b over 2a, we can find that minus b is minus 9 over 2 times 6. This gives us 3 over 4. Which means that the minimum value at n is equals to 1, and it also then means that Tn is increasing for all n values that are within the subset of n. So if n is equals to 3 over 4, that means the smallest value is a positive value, and therefore our graph is increasing. Yeah, another way you could also find this out is by getting the first derivative of our function. If you get the first derivative, you get 12n minus 9. Then you just want to check when this is positive or when it's greater than 0. And you also find that when n is greater than 3 over 4. So show that the pattern is increasing for all values of n. Within the subset, we know that the subset starts from 1. So if the smallest value has to be a value that includes 1, that means all the values are included. Because we are saying here 0, and then we have 3 over 4 here, and then we have 1 here, and then 2, and then going onwards. And we're saying that for the smallest value we have, it has to be greater than any value here, which means it includes 1 and all the values that come after 1, which are all the values that are possible within a pattern. Therefore, that's the answer.